Hi guys, this video is about local maximums, local minimums, and the second derivative test. So to start out with, I've drawn a function y of x, which is kind of lumpy. It's very convenient for this type of discussion. What we're going to do along y of x is we're going to draw some tangent lines. We're going to draw some tangent lines at certain values. So let's take this point here. Suppose this is x1. Then the tangent line to y of x, the tangent line to the function y at the value x1, I guess looks something like that. Maybe it's more steep. Maybe it's steeper. Okay, so yeah, it looks about like that, I guess. Let's say that this point here is x2. This point here is x2. Then the tangent line at this point is going to be completely flat, actually, because x2 is supposed to be the point that's at the top of that little hill there. Need another color now. I guess I'll use red again. So this point here is going to be x3, just to be original, x3. And the tangent line at x3 looks, I guess, something like that. Really hard to draw these things, actually. I guess it looks something like that. Should be, just kind of just touching the curve once. That's what the tangent line should look like. So it's touching at that point. And then finally, x4 down here. Wait, not finally. We've still got some to go. x4 is kind of at the bottom of that hill. It's going to be completely flat. x5, we'll do a couple more. x5, that's going to be our tangent line at that point. And finally, x6 at the top. x6. Oops. And the tangent line at the top, again, will be completely flat. So just to recall, the function y prime of x, the function y prime of x, when we differentiate the function y of x, y prime of x tells us the slope of the tangent line for each value of x. For example, if I take y prime of x1, well, y prime of x1 is going to be, well, approximately 1, just from this diagram, because that line there looks like it has a slope of 1. So y prime of x1 is approximately equal to 1. Now y prime of x2 is going to be equal to 0, because x2 is such that it's right at the very top of the hill. It's right at the top of the hill. And so if I put a tangent line to the function at that point, that tangent line is going to be completely flat, which means it has a slope of 0. And so y prime of x2 is equal to 0. Y prime of x3, again, that's approximately equal to -1, because this line, well, it's a little steeper than that the way I've drawn it, but we're just going to say it approximately has a slope of -1. Diagram not drawn to scale. And finally, y prime of x4, again, that's equal to 0, because x4 is the point at the bottom of that little hill there, the value of x that gives the point at the bottom of that little hill on the function. So y prime of x4 is equal to 0. Just looking at these tangent lines, and let's just draw a few more in for dramatic effect. Here, draw one here, draw one here, one here, one here, one here. Okay, so those green ones are also tangent lines. I know they're drawn pretty badly, but you get the idea. So we can get an idea of what y prime of x looks like by looking at the slopes of the tangent lines. So let's take this section here. First of all, I want to know what's actually happening to y prime of x. What's happening to y prime of x? I know that y of x is getting bigger, but what about y prime of x? Well, if we look down here, the slope of this tangent line is actually pretty steep. So the value of y prime of x at that point is going to be quite high, because that line has a big gradient to make the line so steep. Whereas the value of, well, the gradient of this tangent line is not as much, because the line is not as steep as the previous one. And actually, all these, these tangent lines, their slopes are actually getting smaller and smaller. The slopes of those tangent lines are actually getting smaller and smaller until finally, right at the very top, they get to 0. So in fact, along this part here, y prime of x is actually decreasing. Y prime of x is actually decreasing. How about on this section? How about on this section here? Well, the same thing. Y prime of x is still decreasing because even though the tangent lines are starting to get some slope back, it's actually a negative slope. They're getting steeper and steeper in the negative direction. And so that's still going down. We're still going to get a smaller and smaller number. So y prime of x is actually decreasing pretty much right until about there. It's decreasing until about there. Because, well, I'm going to say that x3 is the point for which the slope is the most negative. Because what happens after x3? What happens after x3? Well, you can kind of see, and I know it's a bit of a bad drawing, but you can kind of see that the tangent lines are actually starting to get a bit less negative. They're starting to get less negative. And if they're getting less negative, that means they're actually getting bigger. Because the more negative something is, the smaller it is. The more negative a number is, rather, the smaller it is. And so the less negative a number is, the bigger it is. So the tangent lines are actually getting less and less negative. And so on this interval here, use this color, I hardly ever use purple. On this interval here, y prime of x is actually increasing. And it continues to increase all the way up to about here. Those lines start to get more and more positive past this point, right until they hit this point here, right until they hit that point x5. And then after x5, they kind of start to, decrease around again, right until they get to 0 on top there. So between x4 and x5, y prime of x is also increasing. So y prime of x is increasing on this entire interval here. And then it starts to decrease again. Go back to green. Y prime of x starts to decrease again, from here onwards. And then, the cycle kind of repeats itself. So y prime of x, first it's decreasing, and then it hits 0 here, and then it keeps decreasing until it reaches the most negative number it is at x3, and then it starts to increase again right until it gets to 0 at x4, and then it keeps increasing until here, and then it starts to decrease again. So y prime of x, if I'm going to draw that, I'll draw y prime of x. Y prime of x looks kind of something like this. So first it's decreasing, and then it hits 0 when we get to the top of that hill, and then it carries on decreasing, and then it reaches the most negative it gets to, then it starts increasing again, and then it hits 0 when we get to the bottom of that hill, and then it starts increasing again, and then it increases to the most that it possibly increases by, then it starts decreasing again, and then it finally gets to 0, and the cycle kind of continues. So this is what y prime of x looks like. This is what y prime of x looks like. We're going to come back to this graph, so don't discard this graph yet. So that's the x-axis, and this is the y prime axis. So that's what the graph y prime of x looks like. Okay, well, something else that we can observe about this point x2. If I draw a red circle around x2, then x2 gives the biggest value of the function inside that circle. Let's kind of zoom in on this a bit. So if I draw that red circle around the function, it looks kind of like this inside the red circle. And here's x2 right there on top. Now we call x2, we call a point like this where you can draw a red circle around it and have it be the biggest in the circle, we call that thing a local, we call that thing a local maximum. Call that thing a local maximum because we can choose a neighborhood around it, we can draw a circle around it, and inside that circle it's the biggest value in that circle. So we call that a local maximum. Similarly, we can draw a red circle around x4. And if we draw a red circle around x4, the function looks like this inside that circle with x4 at the bottom there, x4. And in this situation, we say it's a local minimum. Local minimum. So x2 is a local maximum and x4 is a local minimum because we can choose a neighborhood around them where they are the smallest in their neighborhoods. Okay, I've been talking for a while, so we're going to stop there. We'll continue with this lesson in the next part. Thanks very much for watching. Take care. Bye.